The next topic for today is related to beam steering, focusing on 5G networks in WinProp. So to put things in context, when we compare 5G networks to 4G networks, we mainly know that 4G in 4G networks, the different users are served by normally base station sector, whereas in 5G networks, the main difference is that they provide higher capacity by using individual beams per user within different sectors, but also by adding small transmitters and cells that could be mounted, for instance, on lamps, posts, and others to serve the local traffic. So the fifth generation network planning has several characteristics that should be accounted for, and such as, for instance, the use of the antenna arrays at the base stations that can direct relatively narrow beams to individual mobile stations, or what we call end users. And as base stations are changing the directions in which the beams are pointing to serve the different mobile stations, their coverage also changes as well as their interference. So this leads to simulation approaches that can differ from the ones used for pre-5G simulation networks. So there are three different simulation approaches for 5G network planning. And of course, we are speaking here in the scope of WinProp. So the first possible approach is to specify an omnidirectional antenna or multiple antennas at the base station level. And when you do this in a 5G network planning project, in ProMan, you enable you can specify additional antenna gains to account for beamforming in specific directions. And this is usually done at the carrier assignment level. Now, the second interesting approach is to simulate with the envelope pattern of all possible beam patterns. This assumes actually that if a given mobile station is in the cell, the base station array will direct its best beam at the mobile station. So for that specific mobile station, the gain of the envelope pattern will be equal to the gain of the specific beam, although the envelope includes all the possible beams. And the propagation result is still correct in that case. And the final possible approach is to simulate with individual beams. And this requires the knowledge of where the mobile station is exactly at, and it is usually combined with Monte Carlo also analysis. It is important to note that actually you are able to generate these envelope patterns and individual patterns using the antenna manager tool within WinProp, and it allows you to specify the antenna patterns properties, specifically the control beams and the data beams in different areas of the tool. And you can also convert individual beams that you have already access to into an envelope beam. So either you create everything from scratch, or you have already ready to use antenna patterns that you can combine into beams that you could later on use in your radio network planning analysis. Quickly going overview the features that we have in WinProp when it comes to 5G network planning. So we start by the different propagation models that were extended and were verified for 5G frequencies. So the 5G air interfaces that are supported allow for a wide range of bandwidth up to 400 megahertz. And of course, depending on the numerology of the different subcarrier spacings, we can also specify slot length and so on. And usually all these parameters are configured in using the WinProp GUI when defining a new 5G radio planning project. So based on this, the user can simulate different beam pattern configurations and also evaluate the different configurations regarding the signal and interference situations, as well as possible throughput. Focusing more a bit now on beamforming. So the main benefits of beamforming are mainly to increase the received signal gain by making signals emitted from different antennas add up constructively, and it reduces the multipath fading effect. Now, sometimes spatial multiplexing can also be combined with beamforming when the channel is known at the given transmitter. For massive MIMO antennas, they are used for beamforming that allows us to transmit different signals to different mobile stations using the same frequencies and time resources. And this increases the received power levels highly and allows for quite a better signals-noise interference ratio. And in this example, actually, we compare the coverage results in case of a beamforming for two different users, and it's in an urban environment. So this is a top view. The gray parts you see are the buildings, and we have the coverage results in the streets around the transmitter. And so the upper, actually two pictures, so show the coverage using antenna patterns defined for a 4x4 antenna, and the lower ones that were, so the antenna patterns generated using a 16x16 antenna element. And it is clearly seen that for the lower two cases, where the beams are pointing in a more directive way, so the more antenna elements you have, the more you can separate users actually while performing the beamforming analysis. And now coming to the main topic of today's presentation, which is beam steering. And beam steering by itself, or what we could also call beam management, is based on a phased array antennas where the signal phases that are fed to the antenna elements are adjusted to form focused beams in desired direction that can track the movement of the user. For instance, here we see that the user was in the beginning at a location closer to the base station, and then while moving further away, we see that the beam from the base station has adapted and moved accordingly to serve that end user better. And ProMan within WinProp supports this type of beam steering analysis in 5G networks, and this can dynamically also direct the radio signals towards specific users. This, of course, helps improving the signal strength and quality. So to understand all this better within the tool, we will go through a demo together where I will try to show the workflow that you could follow in WinProp in the case of an urban scenario, and to how to manage this type of simulations. So actually what we have here is an urban scenario. As you can see, we have buildings and we have a transmitter that is represented by this blue icon. And we also have actually a user that is moving along this orange trajectory between the streets, or on the streets between the buildings. And sorry, let me go back. Okay, so this is the typical scenario that usually we would be interested in seeing the effect of beam steering in urban scenarios. So we will start with the first step. So switching to the 2D view as usual when we want to change anything. We will start by applying the antenna masking, and this is available in the project parameters menu under the network tab. And we should just make sure that we have activated the apply antenna masking for network planning under the network simulation mode. And then we will move on to defining the antenna array by defining the transmitter and the antenna properties. And you will have access to an option which is antenna array. And once you click on the settings after choosing that, you will have a window that allows you to create your antenna array. It could be based on simple dipole element, or if you have also an external file, for instance, generated using FICO for the base element diagram, you can also use that. And you have also other options that you could set, such as the number of elements in your array and the spacing of the elements and so on. So here we are using an 8 by 8 element array, and with the spacing of lambda over 2. So now that we have set our transmitting array, we will start by defining the user position. For that, from the simulation tab, we will switch our simulation mode to point mode from the drop-down list. And we will create a point that will represent the starting point of our moving user. So we should make sure that we are defining this point as user point. Normally by default, it is set as prediction point. So we should switch that to user point. And here we can set the coordinates of the point in latitude, longitude, and also the height above the ground. The second step is to assign a trajectory to this point, and this is done in the trajectory section. You can define trajectories by defining them point by point manually, or you can also import them using ASCII files where you have already set all the coordinates of the trajectory of the user point. So once that is defined, we will go back to the simulation tab, the main window, and we will switch again to area prediction mode. So the basic default rectangular area prediction mode in WinProp. And the last thing to do here is also to activate the time variant simulations. In this case, we will set our simulation to go through 40 seconds with time steps of 5 seconds over the trajectory of the end user. Now that that step is done, we will run the simulations. So we will choose the run all to run both the propagation simulation in as a first step. And once the propagation prediction is performed, the network analysis is also run. And now we can try to view the results, and we will see how the results show us the beam steering, let's say, a feature of the base station. So to see that, we can, for instance, choose to view the received power for the data channels. You can also check out the received power for the control channels. So first, we are viewing the received power at in the whole area, given the user position that was defined at T0, and then we can move at different points in time over the trajectory. And here we see each time the user is moving along the trajectory, it is clear that the beam that is steered actually by the base station is doing its best to follow this end user to serve it with the best performance possible in terms of signal and received power. So here you see again how that is being simulated in the tool, and you are also able to view that in the 3D view. So if we switch to the 3D view instead of the top view, you will see the whole 3D environment and how the beams that are being managed at the base station level are performing the beam steering. So these are the main steps you need to follow to be able to get to this type of simulations for you to try to best analyze any 5G urban system you have. And this concludes this demo related to beam steering in WinProp.